Alright, this is chapter 3.2, core vocabulary. Start off with axis of symmetry. An axis of symmetry is a line that divides a parabola into mirror images, and it also passes through the vertex. So here we go. A line that divides a parabola into mirror images. Now, this isn't just linked to parabolas. You know, absolute values have axis of symmetry, things along those lines. But it also passes through the vertex. Okay? So, for example, if I've got a graph that looks kind of like this. Alright, let's see here. Let's be a little more specific. So, I got 1, 2, 3, 2, that's good enough. So, if I got a vertex right here, points like that, I got a graph that looks kind of like this. Okay, this is the graph. This is f of x. Wow, that's horrible. F of x better equals 3x squared minus 6x plus 1. Okay? The axis of symmetry, I'm going to call it the AOS. Axis of symmetry is x equals 1, because that line, there's no need to dash it, just make it solid. That line makes it mirror images, and it passes right through the vertex, right there at 1, negative 2. Okay? Standard form of quadratic is a quadratic written in the form f of x equals ax squared plus bx plus c, where a cannot equal 0. Again, the reason a can't equal 0, because if this equals 0, that goes away, and you're left with a linear. Alright? The others can go away, and it's still a quadratic, but the a cannot be 0. So, for example, you can say, y equals, 2x squared plus 3x. It's missing the c, but hey, this is a quadratic. Or it could have the c plus 6. That's still a quadratic. Okay? Let's keep moving. Alright, minimum value and maximum value. Basically, they're both a y-coordinate, but let's start with here. Minimum value is a y-coordinate. Y-coordinate of the vertex when a is greater than 0. Okay? And the maximum value is the y-coordinate of the vertex when a is greater than 0. And here's what I mean by that. So if a is not greater than 0, a is less than 0. Sorry. Here we go. Here's what I mean by that. When a is greater than 0, let's say we get a graph that looks like this. And this is the vertex 3, negative 1. Let's just call it that. Alright? This is when a is bigger than 0. Alright? That is a minimum. In this case, a is bigger than 0 because it's pointing up. Alright? So the minimum equals negative 1. Alright? Over here, let's say we got a graph that looks like this. Let's say this is the point 3, 4. Okay? And this is when a is less than 0. When a is less than 0, that first letter, that first number, it opens downwards. So instead of a minimum, it has a maximum. So the max equals 4. That's the highest that it goes. Alright, last but not least. Intercept form is a quadratic written in the form f of x equals a. You still got that a value, but we're going to go x minus p and x minus q. And again, a cannot equal 0. Again, because a equals 0, if a times any of this is a times all of that, all of this would equal 0, and it would become a constant function. Alright, that's why a cannot equal 0. So, for example, f of x equals 2x minus 3 and x plus minus 1. And you'll realize that this one, the x-intercepts, the reason this is powerful is because if I set those equal to 0 and solve for x, those are my intercepts. I can graph this real fast at 1 and 3. We have to do a few tricks to figure out where the vertex is and all that sort of stuff, but it gets me to a graph really quick.